All right. So, welcome back. So, we are live right now. So, I welcome all of you to this amazing platform of Tutee Learning. So, welcome back to this amazing platform of Tutee Learning. And today, we'll be continuing our discussion on three-dimensional geometry. Okay. So, let's start discussing on 3D geometry. All right. So, as of the last lecture, we have seen that how do we represent the equation of a straight line in space. So this is where we finished up in our last class, where we solved few example questions, and those questions were taken from the previous year IIT JEE problems, right? So we have discussed those questions of angle between the straight lines in space, right? And where we ended with our discussion. So in this particular lecture, we're going to start our discussion with another very important topic, that is going to be discussion on how we can reduce a Cartesian form of equation to vector equation and vice versa. So we're going to start with reduction of Cartesian form of equation to vector form and vice versa. Alright, so we're going to discuss about how we can reduce the Cartesian form of equation to a vector form of equation and how do we do the opposite way, right? So in this particular lecture, we're going to see the important aspects of why do we need to actually convert or reduce this Cartesian to vector, and sometimes it is actually going to be helpful, right? Now the generic way, we have seen that if we need to write the equation of any line, let us say the line equation, the line is given as L, the equation of the line is given as, so let us say the fixed points on the line is x1 and the direction ratios is a, b and c, and the fixed point is x1, y1 and z1. So this is how I can represent the Cartesian equation of any straight line in space. Alright, so now if I need to convert it back into the vector form, we have seen that we can do it very easily, because the vector form of equation looks something like a vector plus lambda times of b vector. Okay, so where a is my position vector of that particular known point and my b vector is the direction ratio of the direction of that particular line. So this is where we discussed in our previous class. So this is both of them is denoting the same equation of the line. Now the question is that you will be given the equation of the form of the equation of the line in this particular format, and you have to easily convert it back into this particular format. That can be easily done, saying that where the position vector of point A is given as x1 I cap plus y1 j cap plus z1 k cap. So this is how I can represent the position vector of the point A. And similarly, or this should be given as, let us say, point A, and similarly the direction ratio of the line is given by b vector, that can be written as a I cap plus small b j cap plus small c k cap. This is how I can represent my direction ratio vector of the line and a given point on that particular line. So this is how we can solve or reduce the equation of any line to the vector form or vice versa. So generally in the questions, you might be given any one of the form, and depending upon the type of questions, you will have to reduce it to your use case, right? So this is where we need to understand and apply it to questions as and when necessary. Alright, so with this part, let's go on discussing about how to find out the point of intersection of two lines. So let us say I need to find the intersection of two lines in space. So if I need to find the intersection of two lines in space, how can I do that? That is very simple, that whenever two lines intersect at a common point, the coordinate of the point will lie on both the lines. So let us say that this is my line number 1 and this is my line number 2. So if I have the equation of the line corresponding to the cases as follows, let us say this is my lambda and my line 2 is given as some mu. Alright, so if we have this following construction of the problem, and if I say that the common point where the lines are intersecting, let us say that particular point is P, and that is a unknown point or a variable point, let me denote it by x, y and z. Now, if I need to find out the coordinate of this particular point of intersection, the simple way is to find out this point P from line 1 and line 2, and then I have to compare it, and from there I will get the value of lambda and mu, which will come from the point P. Very simple and straightforward. So let's try to analyze this particular idea. So I can write point P as so it will be some x1 plus lambda times of a1 comma y1 plus another times of b1 and comma z1 plus lambda times of c1, which will be same as the point given as x2 plus mu times of a2 y2 plus mu times of b2 comma z2 plus mu times of c2. So this is how I will have this equivalence relation, right? So from here, if you take any two part, let us say I take this part and solve with this part, I will have one equation in lambda and mu, and another equation can be taken from this part and this part. So if I try to solve these two equations and two unknown, from there I will get the value of lambda and mu. Now please note that once you obtain this value of lambda and mu, please try to put that back into this last z coordinate. Okay, so please try to put it back in the z coordinate and check for whether you are getting the same z coordinate or not by putting lambda and mu in this respective position. So if you do that, sometime it might happen that the z point might vary. So in that case, the line is not intersecting. Okay, so it might look that the line intersect in one particular plane, but it won't intersect in the other plane, right? So there is a very important consideration to understand that in order to line to be or a point, then in order to be line to intersect at a particular point in three-dimensional space, all the x, y and z component should be simultaneously equal, right? So please check this particular part then before you are saying that the line intersects. Okay, it might look the line intersect in one particular plane, however it does not intersect in the other, so it might happen, right? So please carefully note this particular thing before you are going for saying that the line is intersecting in reality. All right, so this part we can, so once this part is clear, we can now move about to discuss about another two important topics, that is the foot of perpendicular and finding the mirror image of any point by about the straight line. All right, so let us try to move on to that particular discussion, but before that I want to ask all of you, is this particular formulation clear to all of you? Is this part clear? So we now need to move to understand about how we can find out two important forms or properties of straight line in space. That is, first of all, we will solve for finding out the foot of perpendicular from any point A, which is given as alpha comma beta comma gamma, to the line in space, and that particular line is given by some equation, let us say x minus x1 by L is equal to y minus y1 by m is equal to z minus z1 by n. So let us have this as my line, and the point A is the given point. So from which I have to find out my foot of perpendicular, right, to this particular line. So how am I going to do or solve this problem? It's fairly straightforward. So let us first of all analyze the situation. So this is my line in three-dimensional space, and this is my point which is given as A as alpha comma beta comma gamma. And from here what I have to do is that I have to project, or I have to drop a perpendicular line like this. So this particular line, let us say it is intersecting at point O, which is a perpendicular line. So what I am seeing that my AO line is perpendicular to this particular line. So what I can conclude over here, that since these two lines are perpendicular, I can form vectors like this one vector and another vector which is directed along the direction ratio of this particular line. And we can see that these two vectors are therefore perpendicular to each other, and from there I can conclude with the result, that is, let us say the L vector denotes the direction along the line. So OA dot L vector should be equal to 0 because they are perpendicular to each other. Right. Now, how do I find this particular point O? For that, the interesting way to solve this problem is to assume this general point O. So let us assume the general point O in terms of lambda. And that will come out as x plus lambda times of L, y1 plus lambda times of m, and z1 plus lambda times of n. So this will give me the coordinate of the point O which is lying on the line. Now, once I have this coordinate of point O, I can easily form the OA vector. So OA vector will be obtained as alpha minus x1 minus lambda times of L I cap plus beta minus y1 minus lambda times of m j cap plus gamma minus z1 minus lambda times of n k cap, and this will be my OA vector. Now once I obtain my OA vector, so, and I already know the direction ratio along the line is given as Li cap plus mj cap plus n k cap, right? So from here I can solve for, this particular equation, that is OA vector dot L vector should be equals to 0. So from here I can solve this part to get my value of the unknown, that is my lambda. So from here I'll get to the value of my lambda. Once I get the value of the lambda from here, I can easily substitute this lambda in this point O, and I can obtain my O, which is the foot of perpendicular, right? So from here I will obtain my point O, which is the foot of perpendicular from point A, which is given as alpha comma beta comma gamma. Alright, so this will generate me the foot of perpendicular for the given line, or for the given point on a given line. I hope this part is clear to all of you. Now once I obtain the foot of perpendicular, now from this particular result, obtaining the mirror image of point A, considering this straight line to be a mirror, won't be a difficult problem. So I can easily do that by applying, so let us say this is A dash, which is given as alpha dash, beta dash and gamma dash, which is my mirror image. So let us say this is my mirror image, and this is my mirror, right? So once I consider this as my mirror and the point A, so to find out the mirror image of point A, which is A dash, now this can be easily found out by using this simple midpoint formula. So from this particular formula itself, I can find out that alpha plus alpha dash by 2 should be equal to the x coordinate of this O point. So x coordinate of O point, which is given as x1 plus lambda times of L. Similarly, my beta plus beta dash by 2 should be equals to y1 plus lambda times of m And similarly, I can obtain gamma plus gamma dash by 2. I can obtain gamma plus gamma dash by 2, that should be equal to z1 plus lambda times of n. So once I know the value of lambda, I can easily obtain the foot of perpendicular as well as my mirror image. So from this particular formulation, we can solve two of the very important problems. I hope this is clear to all of you. Is this part clear? Please let me know in the live chat, is this clear or not? Okay, this is going to be very important, and we will see some following problems where we're going to apply these few concepts. Okay, it might look a bit of a tedious calculations. However, if you practice this more than a time, then I think it won't be any difficult issue. So the practice is the only key over here. Okay, so please try to practice these kinds of problems so that you can understand and also apply it to the different questions. Okay, so keep on doing some practices so that in the examination hall you don't make up silly mistakes in the calculations. Okay, so that is a very important note. All right, now another important question that can be also asked over here is that you may be asked to find out this particular form or the perpendicular distance of a point from a line. So you might be also asked to find out this particular distance, that is why OA distance, right? So in order to do that, it is very simple. You can easily do that by considering the OA vector and find out the magnitude for my OA vector, and that will obtain you this particular perpendicular distance. However, there is another interesting way to do the same question, is that by using the concept of projection. So what I'm trying to say is that, let us say the situation is something like where AB is a straight line in space which is acting like the mirror, and my point P is the point, and my Q is my image. Okay, and let us say this is my L line. Okay, so let us say this L point is the point foot of perpendicular of this point P onto this straight line AB, right? So what I have denoted that my AB line is given some equation something like this. Like, let us say the equation of this AB line in space is given by this vector equation. Now if I have this equation, now R denotes the position vector of this particular any point on this particular line. Now what I'm trying to say is that, let us say then the position vector for point L will be also be given as A vector plus lambda times of B vector, because R is the any general point on the line. Right, now once I obtain this result, what I can conclude and say is that, let us say the position vector of point P is given as alpha vector. Okay, so what I will do is that I will try to, because I know my point A, which is a fixed point, I will try to form a vector like this. So this is my PA vector, or we can call this as, like, you can do it other way as well. All right, so I am doing it by PA vector, and that will be obtained as A vector minus alpha vector. Right, so I have obtained this PA vector. Now if I try to find out this point, this angle between this line vector and this PA vector, I will obtain this angle, and from this if I try to find out this particular LA distance, which is just the component or the projection or the horizontal projection of this particular PA vector onto this AB line. And similarly, if I find out the perpendicular projection of this PA vector, I will get this PL vector. So what I can do is that I can say this PL vector is nothing but it is a perpendicular projection. So this can be obtained as, so I can apply my vector triangle law of vector addition, that is A vector minus alpha vector minus this AL vector. So AL vector can be given as, so I have already discussed about this in my vector algebra courses. So A minus alpha vector is this PA vector dot with the B vector divided by mod of B vector, that will give you the projection onto this particular vector, and we need to multiply with B cap. So there will be square over part over here because I need to write it as B vector. So I have just replaced this unit vector with b vector upon mod of b vector, that makes it square over here, right? So if I try to find out this by the following notation, I am easily going to get the PL vector, so or this particular perpendicular line vector, right, in a much easier way as well, right? So you can see this is also another interesting way to obtain the same relation, right? However, I don't suggest you doing this particular calculation in the as a beginner. However, doing this coordinate transformation thing and assuming the coordinate thing as a vector and doing this following calculation, I would suggest to go by this particular method. Alright, you can obviously try by this particular method. Maybe as a part of an exercise for any particular question, you can take up this problem and you can solve it by these two following methods. Okay, so please try to do that. Alright, so and this will be very simple, right? And again, to obtain the position vector of point Q, let us say that is given as beta vector, and that can be easily obtained once I obtain by the midpoint formula. Alright, so that is alpha vector plus beta vector by 2 will be just the L vector, that is my, or let me say that the position vector of point L, okay, that is given as small l vector 1, or okay, just to differentiate it from the line vector thing. Alright, okay, I have already said that it is L vector, so I should write it as L vector, not 1. Anyways, so this is how I can obtain the result for the beta vector as well. So once I obtain this L vector, I can do any of the following modification to find out the given results. Okay, so I hope this is clear to all of you. I hope this result is clear to all of you. It's a quite an important result, so please note that this is going to be very helpful, especially when you will be solving JEE Mains and Advanced previous year questions. So you can check on the previous year JEE Mains and Advanced problems. You will have a lot of questions, especially from this particular topic of foot of perpendicular and images. Okay, and also in the upcoming part of the lectures, we will be discussing about another important concept, that is the problem of when two lines lie on a same plane. So that is also another very important problem. So we will be discussing about that in our upcoming lectures. Okay, is this clear to all of you? So let us now move to solve one question. Okay, so I would like to give you a question to solve. So please take this particular problem. So the problem is very simple. You need to find out the image. You need to find out the image of a particular point in a straight line in space. So please try to solve this problem by whatever you have understood so far. Okay, please try to solve this problem. So take your time and try to solve this problem and let me know the final answer in the live chat. Now, along with this, there is another very important set of questions that can be also asked regarding the distances that can be easily tackled by these vector concepts. Okay, by this particular vector concept. We will come to that particular discussion, but in the meanwhile, please try to solve this problem. Please try to solve this problem. This is a very simple problem where you have given the equation of the line as follows, where my equation of line is given as follows. Alright, so this is my equation of my line. This is the equation of my line, and there is a point P over here which is given as 1, 6, 3, which is given as 1, 6, 3. Right, now I need to find out the image of this particular point. Let us say that image is Q, and let us say that image point is given as by alpha, beta and gamma. Alright, so this will be perpendicular line. Now in order to solve this problem, there is another method to solve this problem, is just by not to directly find out the foot of perpendicular. Rather, you can form this PQ vector and make it perpendicular to this line vector. Also, you can find out the midpoint of PQ line and satisfy in this equation. That is another easy way of doing it. So let us try to go it by the easy way. So if I try to form my PQ vector, that will be easily obtained as alpha minus 1 I cap plus beta minus 6 j cap plus gamma minus 3 k cap. Alright, so this is how I will obtain my PQ vector. Okay, now this PQ vector would be perpendicular to this line vector, so that is going to be the dot product of that is going to be 0, where my line vector is simply I cap plus 2j cap plus 3k cap. Okay, this is how I will obtain my line vector. And so if I perform this dot product over here, I can easily solve for alpha minus 1 plus 2 times of beta minus 6 plus 3 times of gamma minus 3 should be equal to 0. So from here, I will obtain a equation in alpha beta gamma, that is alpha plus 2 beta plus 3 gamma should be equals to 1, 12 and 9. So 22, right? So I will obtain a equation in alpha beta and gamma. Now another set of equation would be obtained by just finding out the midpoint. So the midpoint, let us say that is point R, that is alpha by 2, alpha plus 1 by 2, beta plus 6 by 2 and gamma plus 3 by 2. So this particular point will be satisfying this equation of straight line. So I can satisfy over here, and so if I put that over here, alpha by 1 by 2 is equals to beta plus 6 minus 2 by 4 should be equals to gamma by gamma minus gamma plus 3 minus 6 divided by 6. Alright, this I will have a convergent relation. So alpha plus 1 by 2 is equals to beta plus 4 by 4 is equals to alpha minus 3 by 6. Okay, so I will obtain another relation over here, and which I can assume as some lambda, let us say this is a constant lambda, and I can obtain alpha as 2 lambda minus 1, I can obtain beta as 4 lambda minus 4, and I can obtain gamma as 6 lambda plus of 3, right? And this I can put it in this particular equation to solve for lambda. So if I put that in the following equation, so I will have 2 lambda, so I will have 2 lambda minus 1 plus 8 lambda minus 8 plus 18 lambda plus 9 is equal to 22, which I can solve it as, so this will become 28 lambda would be equals to, so minus 9 is equal to 22. So lambda I will have it as 22 upon 28, which is 11 upon 14. So I will have the value of lambda. Now once I have this value of lambda, I can easily put it back into my following equation to obtain the alpha beta gamma, right? So I will obtain easily from here my image point, right? So alpha beta gamma can be easily obtained from here, and that will be my following answer. All right. So I think maybe there is some calculation error from my side. I have to check it over here. So you can check it. Okay, maybe you can check this part out. So okay, there is a calculation mistake over here. It should be minus of 1, gamma minus 1. Okay, it should be gamma minus 1, and that is equals to lambda. So it will be 6 lambda plus of 1, and if I put it back, so it is going to be over here, it is going to be 3, right? So minus 9 plus 3 is minus 6, and that will come out over here as 28. So from here I will obtain my value of lambda as 1. Okay, so please correct this part. Okay, the value of lambda should come out to be 1. So from there the value of alpha should be 1, beta to be 0, and gamma to be 7. So this is my following result. So my coordinates of the image is 1, 0, 7. I hope this is clear to all of you. Okay, this is another very easy way to solve this problem. Okay, so whenever you have been asked the question of finding out the image of a point on this line, so you can use this particular way to solve this problem. Okay, I hope this result is clear to all of you. So please try to understand this result, because this is going to be very important, especially for your JEE Mains. Okay, mark my words, if you look at the JEE previous year problems, you will find there are a lot of question has been asked, especially on this particular topic. You have a point and a line, and you have to find out the image of that point about the line, or maybe the foot of perpendicular. Okay, so please try to solve these kinds of problem many times so that you get uh, accustomed to solving this kinds of problem. Now you saw in the live example, like when I was solving this problem, I got an error in the calculation, right? So it might happen to you as well, right? So please try to check this part out. Okay, so whenever you are solving, be careful and do the calculation step by step. Okay, don't try to jump the step, because I tried to jump the step over here and I got an issue, right? So please do the calculations carefully, and then you will be easily able to solve the problems. Okay, not a difficult problem yet, very simple, straightforward, just to do some lines of calculations. Okay, that is why I say this chapter of 3D geometry is the most easiest chapter or most easiest portion in mathematics to prepare for, right? So please take this particular thing in your mind, and if you still have any questions, please let me know in the live chat as well as in the comment section after this video is over, right? Or this live is over, right? So with this, I conclude the session over here, and today we finished up our important discussion of a point and line. Now in the upcoming lectures, we're going to discuss about how to find out the distance of a point from a line along a given line, right? That is another set of question that is also being asked in your JEE Mains examination. So we are going to discuss about that in our next class, and with that we'll start about discussing that what is the condition for three lines or two lines to be lying in the same plane, right? So, and also we will try to understand the concept of how to find out the shortest distance between two skew lines which are not lying in a same plane. Okay, so that is a very important idea to understand, that is they are neither parallel nor intersecting, that is called as skew lines. Okay, so we will try to understand the concept of skew lines. Now the skew line concept might be a new concept to you, because in straight lines in 2D you have seen two cases, either they will be parallel or they will intersect. However, in 3D case, they might look they are intersecting in from one plane, however they won't intersect actually, right? So these kinds of set of lines are generally called as skew lines. So in our next lecture, we're going to discuss about the shortest distance between two skew lines, and that will mark the importance, also another set of important question, especially for JEE Mains. And with that, we'll be done with our discussion on straight lines in plane. And in the upcoming lectures, we're going to discuss with planes. So you can think that this particular series of 3D geometry would be more or less wrapped up in just 8 lectures. Okay, so by the end, starting of November, we'll be done with our 3D geometry thing. Okay, so if you are planning for your JEE Mains first attempt, you can consider this particular channel. So please subscribe to the channel and also hit the bell icon, so that whenever we are live, you get a direct notification. Okay, and please note that we are going to start something very big on this particular platform, which is going to come up very soon on this platform, right? So for that, please subscribe and also share these videos among your friends, your juniors, or maybe your relatives. Okay, so that it can help us to reach us to the maximum crowd, right? So that is all for today, and we hope to see you in the upcoming discussion. So very soon there is going to be the one shot revision series coming up for your JEE Mains first attempt. All right, so with this, thank you, and I wish you all the best. Thank you.